The forum is about to begin. So firstly, I would like to welcome you all to this forum about solid state lasers. So first of all, I would like to introduce the forum members today. So my name is Muhammad HAZMI bin Muhammad NAWAWI as the moderator for today's forum. And the other members, Muhammad Syahmi bin HAMDAN, Muhammad SYAFIQ bin MITHLAN, and Muhammad ZAKI HAKIMI bin RAHIM. So I would like to begin the forum by explaining the principle of operation of the solid state lasers. So it's a good idea to start with the basics. So what is the solid state laser and what makes it different from the other type of lasers? So usually all solid state lasers have similar design. Laser rod is mounted near an arc or flash lamp. So we can see in the picture. The lamp is connected to the DC power supply that maintains a controlled current through the lamp. The laser rod and lamp are placed parallel to each other and are surrounded by the reflector. So the H arc, that is the high reflective mirror, and the output coupler are placed at either ends of the laser cavity. So in this picture, we do not show the DC power, but however it exists in solid state lasers. So every laser cutting tool consists of three components. So first is the pump source, which provides the energy to generate the laser beam. The second is the gain medium. The second is the gain medium that provides the photons of light that create the laser beam. And the third component is the optical resonator, which is a set of aligned mirrors that reflect and amplify the photons, creating an intense directional beam of light. Next, the working principle of the solid state laser. So in solid state lasers, the pump energy is actually light. As such, the low power diode lasers, which operate by converting electrical current into light, that is stacked together in groups to provide the power supply for the lasering process. So instead of other medium, the gain medium is for the solid state laser is a solid material, hence the name given the solid state lasers. And the medium that is usually used a crystal of yttrium aluminium garnet YAG dope or coated with an active material. Most often the elements neodymium and DYAG or ytterbium YBYAG. The common cavity of the solid state laser contains two mirrors, the one that completely reflects and the one that reflects in the range of 50% and 99%. So when the lights reflect between these mirrors, light intensity increases as the laser light moves in the same way as an intense beam. This laser will create very bright light. So and solid state lasers are typically optically pumped. As optical pumping is one of the methods that can be used to excite the atoms to a higher energy. This process will illuminate the laser material with light with a higher frequency compared to the laser light. So from the picture, the solid state laser uses a rod of solid crystalline material, which is unpolished, flat and parallel and coated with mirrors to reflect the laser light. So the ions are suspended in the crystalline matrix and emit electrons when it is excited. So the side of the rod are left clear to emit light from pumping lamp, which may be a first gas discharge producing flashing light. Since laser can be focused to a precise spot of great intensity, enough heat can be generated by small pulse laser to vaporize different materials. So lasers are used in various material removal processes, including machining. So that's all from me, and I would like to invite our first speaker today, Syahmi HAMDAN.
So, the process for the manufacturing of the solid state laser, there are 4 overall processes that are included for the manufacturing process of solid state laser. The first is the manufacturing process itself. The second is the assembly process. The third is the alignment process, and the last is the final testing process. In the first process, which is the manufacturing process, in this process, a high purity oxide powder compound is placed in a crucible, and it is placed in a radio frequency furnace at a high temperature until it is melted. Then a seed crystal is then stick with the liquid surface, which is the compound, which is the high purity oxide powder that is melted, and the combination of these two substances will slowly lifted, rotated until it is cool, will form. The second process is the assembly process. In the second process, the optics are integrated with the mechanical components. There is a blueprint that need to be followed by the technician that required the technician to place the optical components in the desired position by using metal holders or mounting device. They use these components to ensure that the optical is not being damaged. The third process, which is the alignment process. In the third process, the laser cavity is aligned to ensure that it operates at its desired specification. And this process is performed by another technician by using another laser to help with the alignment. And the last process for the manufacturing of the solid state laser is the final testing. In the final testing process, there is a testing called as end testing. In this test, they basically check the laser for proper operation in terms of the output power, beam quality, and also other characteristics. And this test will operate for a number of hours until it passes the specification for the solid state laser to operate at its maximum operation. So there is the overall 4 processes that are involved for the manufacturing of the solid state laser. That's all from me.
Thank you, Muhammad Syahmi HAMDAN, for the explanation on the process flow. Next, I will invite our next presenter, Muhammad SYAFIQ.
For type of solid laser, there are several types of solid state laser, which are ruby laser, medium gas laser, medium wide edge laser. Firstly, for the ruby laser is a red solid state laser based on a synthetic ruby laser crystal SK medium. The first laser is developed in 1690 by Jordan Myman. Ruby laser belong to the relatively few solid state visible laser, which most other are emitting in the infrared spectral region. They are constrained 3-level system, which require quite high pump intensities for producing laser gain. Ruby laser are pumped with flash lamp either in the free running mode or with Q switching for nanosecond pulse with higher peak power. But power laser are not widely used. Okay, next is medium glass laser. Glass, which is an excellent host material for indium. Traction for glass, which will develop technology for making large size glass laser. It very high output energy per unit volume of material. Glasses are more suitable for high energy pulse operation because of their large size and flexibility in their perimeter. It can be doped at very high concentration with excellent uniformly. It also can be made in a variety of shape and size. Lastly, the major advantages of glass is a low thermal conductivity. Lastly, is a neodymium wire edge laser. This is made of neodymium ion. The host is YAG, yttrium aluminium garnet. In neodymium YAG laser, neodymium ion takes place of yttrium ions. YAG offer low threshold and high gain. YAG is also a very hot isotropic crystal. This is a good thermal and mechanical properties. It can be grown and fabricated in rod of high optical quality, which require lower pump energy. The efficiency about 10 times as compared to ruby. Lastly, it a drastic weight reduction. Okay, that's all for me.
Okay, thank you, Muhammad Syafiq, for the informative and interesting talk. So without further ado, I would like to welcome our last presenter today, Muhammad ZAKI HAKIMI. Alright, Mr. ZAKI, the screen is yours.
Thank you for the opportunity to be here. Alright, let me share my slide first. Alright, so from here I will talk about advantage and disadvantage and also application of the solid state laser. So the first of all, solid state laser are widely used in the industry as it is useful and easy to use. This solid state laser have various advantage and disadvantage. Firstly, let us discuss about the advantage of solid state laser first. So solid state laser, if it is compared to a normal laser, which is a diode laser, it has a greater number of advantage over a diode laser. This solid state laser can work in the wavelength range, and then diode laser shows a bad performance because it does not have that ability. And then second, the radiation intensity in the output is significantly greater in the solid state laser and more coherent than in the diode laser. So the radiation from a coherent radiation beam in solid state laser is pumped with a higher output radiation density compared to the laser diode, which generate distinct radiation beams. So for the third advantage, it is able to generate a greater maximum power compared to the laser diode as a pump source. The peak power of the laser diode is restricted. Output pass only raise a least number of peak power sum up. In comparison, the solid state laser may store up to several hundred microseconds of the laser diode pump capacity. So the store energy is released by Q switching in a 10 nanosecond pass and has a peak output power of 10 to the power of 4 times that of the laser diode. So for the last advantage of solid state laser is the width of line in solid state laser is a lot narrower compared to laser diode. The basic restriction for the width of the laser line is decreased and the laser cavity Q factorized. The solid state laser material have lower optical loss than in the laser diode. And then therefore the optical resonator may have generator Q factor. So that's for the advantage. And then next, for the disadvantage, the inconvenience of utilizing laser diode are more complicated, efficient and inefficient and cost effective for solid state laser pumping. So their application impose in practice a number of constraints such as the needed overall efficiency, peak power, wavelength, and also radiation intensity. Other disadvantage of solid state laser, you can see as slide, which is in comparison to CO2 laser, the efficiency of solid state laser is
is relatively slow. The big downside of strong state laser is a non-constant occupancy ranging from 1,000 to 20,000 radians. So as with CO2 lasers, output power is not particularly high, and then the power loss happen when the road gets too hot due to heat lasing in solid state laser. So that's for the disadvantage. And then the last one is application of the solid state laser. So solid state laser are widely used in many industries, and these solid state laser are used, for example, in material processing, spectroscopy, ultra short pulse research, multifold microscopy, and medical magnification. For the application, we talk about medical application, which is the solid state are used for in medical application. It used for eye surgery, laser printers, and projector, which are emitting a red, green, blue, which is we call as a RGB as a light source. And then the measurement of environmental instrumentation and the transmission of optical system, and also used for future nuclear fusion implementation. And then for the last application of solid state laser, it also in medical, which is also include investigation of laser radiation interaction in ophthalmology, dentistry, cardiology, and then as well as dermatology with biological tissue. So I think that's all from me. So thank you.
Thank you, Mr. Zaki, for the explanation. It's such a good presentation. So we've come to the end of our forum today. So I would like to conclude from the explanation and what have been discussed for today's forum. Solid state lasers have been designed with more power and faster and shorter wavelengths and better beam quality, which will expand their applications. So the latter type of laser will become more popular for such industrial application as general purpose marking and materials processing, as the costs will always come down and higher powers become available. Hopefully the forum today will be beneficial for everybody. Thank you for your attention.